Let's look at another metric of productivity, FTE. That stands for full-time equivalence. And it comes up frequently on the RD exam, especially in Unit 9 when we study food service operations, budgeting, and scheduling. FTE is the standard way of measuring staffing across all kinds of positions and departments. Whether you're managing dietitians, food service workers, or interns, you need a consistent way to track and compare how much labor is actually being provided. And that's what FTE gives you. The equation is pretty simple. FTE is equal to the total hours an employee works divided by the number of full-time hours. In most settings, that's either 8 hours per day or 40 hours per week. So when we say someone works 1.0 FTE, we mean they're working a full-time caseload. If they work 20 hours a week, they're at 0.5 FTE. This is just another per equation. We're measuring how many hours are worked per one full-time schedule. But this also means FTE is an equivalent statement. If we know that 1 FTE equals 40 hours per week, we can use it as a conversion factor in dimensional analysis. Just like we converted grams to kilograms or patients per hour, we can convert FTEs to hours or hours to FTEs. This means that FTE isn't just a label, it's a tool, and we can plug it into a wide range of problems, and we will. Let's start applying it. And remember to try these problems on your own, and if you get stuck, I'll be right here. Here's a super common question. Let's say a dietitian works 30 hours per week. What percent of an FTE is that, or what is their FTE? Well, we already know how to set this up because FTE is equal to total hours worked divided by full-time hours. And you do need to know how many hours is full-time. That's 8 hours a day or 40 hours a week. Since we're talking about the number of hours in a week, we'll divide it by 40 because we're talking per week here, FTE. So the FTE is 30 hours divided by 40 hours, which is 3/4, or 0.75. This worker would be a 0.75 FTE. And remember, FTE is closely linked with percent. So if this problem asked for a percent, like what percentage of work does this dietitian do compared to a full-time dietitian, or an employee who works 0.75 FTE, what percentage of work is that compared to a full-time dietitian? We'll use the percent equation, which is actual outcomes divided by total outcomes multiplied by 100, because percent means of 100. So to convert FTE to percent, we'll just multiply the decimal here by 100. 0.75 times 100 is equal to 75%. So someone working 30 hours per week is working 75% of a full-time schedule, or 0.75 FTE. Okay, let's try another one. This one adds another step because it says a clinic has 10 employees. 6 of them are 40-hour employees, which is full-time. 2 of them are 20-hour employees, that's part-time. And 2 of them are 10 hours, which is like quarter time, or we'd still call it part-time. What is the combined FTE for the clinic? Well, we're solving for FTE, so we need to use the FTE equation here. And in order to use the FTE equation, we need to know how many total hours are worked. That's our numerator. And we'll have to add up the hours of each group of employee in a week. We have 6 employees working 40 hours a week. We have 2 employees working 20 hours a week, and another 2 employees working 10 hours a week. So if we add this up, we'll find the total hours worked, which comes out to be 300 total hours. So to solve for FTE, we'll take our total hours worked, which is 300 in this case, and divide it by the amount of full-time hours. Since we're talking weekly here, full-time hours in a week is 40 hours. So if we take 300 and divide it by 40, we'll get 7.5 FTE. That means this group of 10 part-time and full-time staff members is providing the equivalent of 7.5 full-time positions. This is why FTE is so useful. It's not counting heads, it's measuring actual labor. And remember, we could use this 7.5 FTE as an equivalent statement. If we know the wage per hour or wage per FTE, we can figure out the total salary or budget needed for staffing. So we'll see this again in Module 9. And by then, this kind of problem will feel second nature. Okay, let's try another one. But this one has a little bit of dimensional analysis. So this problem is solving for FTEs How many FTEs can a manager hire at $22 an hour? That's an equivalence statement. There's a per in there. If the department has a weekly salary budget of $9,260. Let's begin with what we know, the total budget, and that's $9,260. The $22 an hour, as I already kind of hinted at, is the equivalence statement. So we can convert our weekly budget into hours. If we have $9,260 to spend each week on labor, and we pay our employees $22 an hour, make sure you're following your units. Dollars goes in the bottom so that dollars cancels out. 9,260 times 1 divided by 22 is 420.9 hours of work. And just as a quick aside, since we're still learning this, this comes from the fact that $22 is the amount of pay you get for 1 hour of work. So we could write this equivalent statement like this: $22 is the value of 1 hour of work. Or we can say 1 hour of work will get you paid $22. They mean the same thing. They're equal to each other, but we need dollars on the bottom because it needs to cancel with dollars in our given. So we'll use this equivalent statement right here. This 420.9 hours represents all the labor time that the budget can cover. But the question is asking for FTEs. So we'll use the standard hours in a week to figure out how many FTEs this is. And we can actually do this 2 ways. The first way using dimensional analysis, which, I'm partial to. 1 FTE in a week is 40 hours. And since those 2 values are equal to each other, we can convert from hours to FTEs. 10.5 FTEs is 420.9 hours. But we don't have to do it that way. We can plug into the FTE equation. FTE is equal to total hours worked. That's our 420.9 hours. Divided by full-time hours in a week, that's 40 hours. At the end of the day, you're taking 420.9 and dividing it by 40. You come to 10.5 FTEs either way. So my general recommendation is that since you'll see so many problems like this, take your time setting up your givens, labeling your units, and follow it all the way through. Let's do one last one together, and then you'll do some more on your own. We'll walk through this one carefully because this is where productivity, FTE, and dimensional analysis all come together. This question says we have a team of 12 full-time employees working together for a total of 480 hours in a week. We're talking about weekly here. And they prepare 6,000 meals. How many meals were prepared per hour by the team? These units here tell us what we're solving for. Meals per hour, which we can write this way. Meals per hour. This will also be an equivalent statement. These 2 things will be equal to each other. But how do we solve it? Well, we know how many meals, and we know how many hours. And we also know how many FTEs. So where are we going to start? Well, I'd start with these 12 FTEs and figure out how many full-time hours is that. Because 1 FTE is 40 hours, they're working 480 hours, which conveniently the problem already told us. That's handy, but not expected on the RD exam. Now, the question asks for meals per hour, which is a productivity equation. So we'll apply the productivity formula, output divided by input. And remember, the output is what we get out, and the input is what we put in. So in this case, the output is the number of meals, 6,000 meals, and the input is our time, 480 hours. And we'll get out 12.5 meals per labor hour, or 12.5 meals per hour. That means for every hour of labor across the team, 12.5 meals were prepared. It's a helpful metric in food service because it'll tell you how efficient your team is. And again, everything here comes back to the units. If the units are set up correctly, FTE to hours and then productivity, meals per hour, you'll always land on the right answer.